So in question 2, we have 2 fair dice that are rolled at the same time. We want to use the tree diagram to determine the probability of obtaining 2 even numbers, at least 1 even number, or no even numbers. So consider the numbers that are on your dice. You have 1 to 6. Okay, and so we are interested mainly in even numbers. So when we make our tree, we'll divide it into numbers that are even here, and we'll mark those off, and not even, we'll put in green here. So we're only interested in whether the number is even or not even, not whether it's some particular number. So we can keep a quite simplified diagram going here. So then we work out the probability of an even number from the dice. And that is 3 chances out of 6, so that's a half. And the probability that is not even is also a half, so 50-50. And on our tree, die 1 is divided between even and not even. So your chance of an even is a half. And similarly, not even is also a half. And then these numbers get repeated on the tree. So half here, half here, half here, and half here. So the fractions are repeated across the tree there. So for our first outcome, we could get 2 evens. We could get an even, not even. We could get not even, even. Or we could get not even, not even. And our probabilities, as we talked about earlier, that these 2 fractions are multiplied. So a half times a half is a quarter. Half times a half is a quarter, and so on. Half times a half is a quarter, and half times a half is a quarter here. And always check that this adds up to 1. Okay, 4 out of 4. Okay, so that would equal 1. So it looks like the tree is correct. If this is not 1 down here, when you add your fractions from the tree, then you may have an error somewhere, so you need to check it again. So our first question. Now we can answer these questions now that we have a tree. So what is your probability of 2 even numbers? So that's EE. So we go back to our tree where the probabilities are, and we select from these numbers here. So 2 even numbers, EE, so that's going to be a quarter. So simply we put in a quarter there, 25%. This one says at least 1 even number. So minimum 1 even number. So that means you could have EE, E not E, not EE. So these 3 have at least 1 even number in them. And when we go down the tree, we add these probabilities. So that's going to be a quarter, plus a quarter, plus a quarter, which will give you 3/4 or 75%. Okay, and not even number. So no evens are allowed. This one here, so that would be this one here, this outcome. So no even numbers will be a quarter, just like that. Okay, in question 3, we again have 2 fair dice and we roll them. We'll use a tree diagram to determine the probability of obtaining 2 multiples of 3, exactly 1 multiple of 3, and less than 2 multiples of 3. So we need to know what a multiple of 3 is first. And those are the numbers from the 3 times table. So 3, 6, 9, 12, and so on. But on your die, we only have 6 numbers. So the multiples of 3 are going to be 3 and 6. So they form 2 numbers out of 6. So your probability of getting a multiple of 3 is 2 out of 6. To get not a multiple of 3, we will have a probability therefore of 4 out of 6. And we'll keep them without simplification for this particular question. So we start to make our diagram, and I've already partially made one. So the first die can either be a multiple of 3, which would be 2, 6 as the probability. And not a multiple of 3 is 4 out of 6 there. So then we can do, again, we continue the diagram to be a multiple of 3 for the die 2, the second dice, and then not multiple of 3. We'll go here. And again, we repeat that for this branch. So multiple of 3, not multiple of 3 here. Okay, and then we will fill in our probabilities. So 2 out of 6, 4 out of 6, 2 out of 6, 4 out of 6. Okay, so they're all completed. And what are our possible outcomes? So we could have 2 multiples of 3. We could have a multiple of 3, not multiple of 3. We could have not multiple of 3, multiple of 3, or not multiple of 3, not multiple of 3. So these are the 4 outcomes you should write down. And then we multiply our probabilities to get the final probability here. So 2 out of 6 times 2 out of 6 is 4 out of 36. 2 out of 6 times 4 out of 6, that's going to be 8 out of 36. 4 out of 6 times 2 out of 6, 8 out of 36. 4 out of 6 times 4 out of 6, 16 out of 36. So you simply multiply these probabilities that are on the branches, and you'll get your 4 final probabilities here. So at this point, you can simplify if you like. So 4 out of 36, that's going to be 1 out of 9, isn't it? So that's 1/9. 8 out of 36. So 4 into 8 is 2. 4 9s of 36. So 2 out of 9. 2 out of 9. Now this one should be, let's see. Let's reduce each by half. So 8 out of 18. 4 out of 9. And we can't go any further. So that would become 4 out of 9. So you can do it without a calculator. Practice your basic skills there. So that's 4 out of 9. So these are your 4 probabilities. And when we add them, you'll get 4 plus 2 plus 2 plus 1, which is 9 out of 9, which is equal to 1. So it looks like we've done the tree correctly because these add up to be 1 on the final step there. So now we can go back to try to answer our questions. So we've got to find the probability of 2 multiples of 3. So that is this one over here, isn't it? This is 2 multiples of 3 here. So this is going to be 1/9. So there's only one branch that gives that answer. So 1 out of 9. Exactly 1 multiple of 3. Exactly 1. In this case, you cannot have 2 multiples of 3. So when we look at our tree, that could only be 1 multiple of 3 here and 1 multiple of 3 here, but not the first one because that's 2 multiples of 3. The key word there is exactly 1 multiple. All right, so in that case, you should have 2 out of 9 plus 2 out of 9. So these 2 probabilities here in green. So that should be 2 out of 9 plus 2 out of 9, which is 4 out of 9 for that answer there. Less than 2 multiples of 3. So less than 2 multiples of 3 would be these ones here. These ones here, less than 2 multiples of 3. The multiples of 3 are here. You have 2 of them, but we want less than 2. So it's going to include these 3 probabilities here. So again, you'll have 2 on 9 plus 2 on 9 plus the last one down here, which is 4 on 9. And that will give you 8 on 9 as your final answer. Another way to do that could have been 1 minus the probability of 2 multiples of 3. You could have done it that way as well. So that would give you 1 minus 1 on 9, which is the first probability, which also gives you 8 out of 9 there. So that's another way you could approach that problem. Okay, and question 4, we have 3 unbiased coins that we tossed at the same time. Use a tree diagram to show the outcomes and determine the probability of obtaining 3 heads, at least 1 head, or at least 2 heads. So these are the 3 questions we need to answer. And so we have an unbiased coin. So that's a key word there. So on a regular coin that's unbiased, we have a head and a tail, don't we? So there's 2 possible outcomes. So your probability of getting a head is going to be a half, and the probability of a tail is a half. So this is the first thing you should note down from the question, the individual probabilities. And I've already started to make a diagram here. So our coin 1 is here, so we can get a head or a tail. Coin 2 is here, head, tail, head, tail. And for the third coin, we need to add them. So we got a head, tail, head, tail, and we continue down repeating those values or those letters, head, tail. So this should give us all the outcomes. And to do that, we've got to put our probabilities on next. So your chance of a head tail is a half. And what happens on this coin doesn't affect the next coin. So these remain as half. So these events are independent. That will be half. And then we go down the last branch. Half, and half at the last one. So our outcomes, we should list them. So we can have head, head, head. So you could get 3 heads. We could get head, head, tail. So just read across the diagram. Then we could get a head, tail, head. We could get a head, tail, tail. We could get tail, head, head. Then we can get tail, head, tail. Tail, tail, head. And tail, tail, tail. So you can see here there's going to be 8 outcomes. 8 outcomes. And for your probability, you can see the probability is going to be the same for each one. So 1/2 times 1/2 times 1/2 is 1/8. So everyone is 1/8. They have all equal chance. So we write them down. All the probabilities are half and half. So our final will be 1/8 when we multiply them. So that's your diagram finished, and you should try to show that in your working when you do your questions. Okay, so what's your probability now of getting 3 heads? So 3 heads is here, yep. And there's only one way you can do that, 1 out of 8. So that's why your probability is 1 out of 8. So your chance then is 1 out of 8, 1/8. At least 1 head. So now we need to go and mark off the ones that have at least 1 head. So that could be here, 2 heads, 2 heads, 1 head, no problem, 1 head, 1 head, 1 head. So you can see here where if you add those fractions, you're going to get 7 out of 8. Or you could do that as probability of 1 minus no heads. 1 minus no heads. and you'll get the same answer, because that would be 1 minus this last number, tail, tail, tail. So that would be 1/8. So you'll also get 7/8. So this is another way you can do that particular question. Okay, now you want at least 2 heads. So 2 heads minimum. So we have 2 heads, 2 heads, 2 heads. That's 1 head, don't include that. 2 heads, 1 head, 1 head, and no heads. So the ones in green are the ones you want. So how many did we get? We've got 1, 2, 3, and 4. So that's going to be 4 out of 8, which is a half. So those are your 3 answers. So 3 heads is 1/8, at least 1 head, 7/8, and at least 2 heads will be 50% or a half.